Hello folks, welcome to Tiny Games Lab. I'm back with a new tutorial. This is a Mahjong Connect game. This is a game that is pretty popular as Onnet Connect or Animal Connect, as you can see on the screen. You have to match the same tiles on a board. By doing so, you remove those tiles, and there are some certain rules that you have to follow to do it. Okay, so in this session what we are going to learn is to use a DS grid and accessors in order to keep track of everything that we're doing in the game. Use recursive scripts, so we're going to be using some scripts that call itself in order to get all the proper lists done for the game and create an awesome game mechanic. This tutorial was asked for by HW. He's a member of the Game Studios forum, so if you guys wanted to check it out, go to Game Studios forum and you can follow this thread for this game mechanic tutorials, and you can ask for your own tutorials. So the games that we're going to be doing is the game that's on the screen right now. So it composed of some tiles, 6 pairs of tiles, and you have to match them by picking 2 tiles of the same type, and you have to get them right. Or to remove a tile, you have to follow some rules, such as any tile needs to be at least adjacent to each other, or in order to go from one tile to the other, you can only make 3 turns, so you have to connect them by 3 straight lines, and if they get connected by 3 straight lines without hitting any other tile, it gets removed. Okay, so what's the game composed of? It's composed of a room, as all the games I have done yet. So the room is going to be composed of some instances, and they're going to be on a grid. I'm calling it an IJ grid, just like I show you on the screen. So we have some tiles placed on this IJ grid, and it's going to be from 0, 0 all the way to, I don't know, IJ position. Okay, so some of these tiles, all tiles are going to be objects, and some are going to be transparent, so they're going to have an image index of 0, and some won't be transparent. They're going to be having an image index of whatever tile they represent, such as you can see on the screen, the X, the plus sign, the squares, the boxes, and the triangles. Okay, and I'm going to have an invisible object controller that's going to control all my movement on this game. Okay, so how does it work? Let me remove some tiles for you guys, and it's going to be working like this. Okay, so when you click your first tile from the 2 tiles you have to pick to remove them, we're gonna save this tile information, this position on Y and J grid, for example, and the image index of the tile, and we're gonna do a first order evaluation. What's the first order evaluation? We're gonna run a loop, that's this recursive script, and we're gonna run and check on the east side to see when we have empty spaces. Then I'm going to go north like this, and we're going to go west and south. Okay, and it's going to keep track of all this information where the empty spaces are on our grid. Okay, so then we're going to do the second order evaluation. It's pretty much similar to the first order, except that we're going to do it for every single empty space that we found on the first order evaluation. So I'm going to check like this. Let's say there's no new empty space. In this case, when we go north, we're going to find those empty spaces. When we go south, we're going to find those. Then we can just keep looping, and we're going to get all the empty spaces that can be achieved by making 2 turns. Okay, so then what we're going to do, when you click on the second tile, it's going to do a first order evaluation on this tile, just like we did on the first tile. So east, west, with north, west and south, and it's going to check if any of those green tiles, or the first order evaluation of the second tile, is actually in the same spot as one of the second order evaluation of the first tile. So if we have any match between a green and a red position on this grid, it means that we have a valid move. If we don't have a match of those positions, we don't have a valid move. Okay, so how is the script going to work to do that? You're going to have one script that's called script first order, script F order in short, and it's going to get an input of an I and J, a vector. so which direction it's going to be checking into, and a list where it's going to save this information. Okay, and the output of this script is going to be the blank spaces that it finds this list. So let's say this tile, this X tile in the middle of the room is on the 3-3 position, and it's going to check to the, and it gets a vector, let's say, to the east. So it's going to check and say, okay, 4-3 is empty. So it's going to recall itself and check it again, 5-3 is empty. Then it hits the end of the grid, so it will stop right here. And we're going to have a second script that's just to make things easier, that's called script check directions. What it's going to do is going to call on, whenever we call it, we input an I, a J, and a list, and it outputs the blank space to this list. But what it's going to do is going to call the F order script on the east, north, west, and south. So for example, we just call it north, 3-2 is empty, then it's going to call the west, and 2-3 is empty, and it's going to call south, 3-4, and 3-5 is empty. Okay, so the purpose of the second script is just to make sure that we call all directions on the first script, and the first script is recalling itself until it finds an end to its vector that's fallen. Okay, so how is our list going to work? So I'm going to use a DS list because I want to use some functions that DS lists have, but DS lists are basically a one array, so I cannot have an I and a J on this list. So what I'm going to do, I'm going to use some formula to do it. So I'm gonna have a cell on this list, and every single row of this list is gonna be my ij, and it's gonna be my I times 100 plus my j. So I have 99 possibles I, 99 possibles j before this starts to get mixed up. And to get my I back, all I have to do is get this value and use a div 100. So I'm gonna get the I value, and to get the j value, I'm gonna do the same, but I'm gonna use the mod function. And this way I can put values into the list, calling them ij, and I can extract values from the list. Okay, so let's say this is when I click the first tile, it's going to generate a list like this, a combination of ij. So the list actually is going to be only the ij code part of it. And I'm going to use ds list, for example, to use the function ds list find index, because let's say I had a list of the first tile that I clicked through, I have the list of the second tile that I clicked, and I want to check for matches. So if I find a match like this green one, it means that I have found a tile, an empty tile that is on both lists, which means that it is a valid move, and I can remove the two tiles that were clicked. Okay, so let's head to GameMaker and see it in action. Okay, so let's start adding the sprites. I'll add a sprite tile. Let me just add my sprite tiles to it. Let me just find them. Okay, there we go. I'm gonna add all of them, and what I'm going to do, I'm gonna add a blank one as the image 0. There you go. And I'm just gonna center the origin of the sprite. And I'm gonna add a sprite indicator. That's just 2 sprites. Second one is gonna be white, and with an alpha, I don't know, maybe let's give it 50%. Okay, there you go. And center it. I'm gonna add my object. I'm gonna start with my object controller. That's the main object of the game. On the create event, let's come add some code. Starting by creating the setup variables. Okay, so rows equals 4, columns equals 6. So I'm gonna have a game that's 6 by 4. I'm gonna add 6 different tiles. So that's gonna have tiles equal 6. And my initial X will be 32 times 2, and my initial Y is gonna be 32 times 4. Okay, that's just the initial position of our grid. And let's start my state machine. So enum state, and I'm gonna have 2 states, the no click state, and no, let's do it, the first click state and the second click state. Perfect. So each state will run when we click the first tile or the second tile. Then let's set up our global variables. Global.myState equals to state.firstClick. there you go. This is our initial state, and global dot first order, that's our initial list, equals to ds list create, okay, and second order equals to ds list create also, sorry, ds list create, perfect. And let's add the first click tile equals 0, and then this is going to use to get the instance of the first tile that was clicked. And let's create our initial list, tiles list equals to ds list create, and I'm going to use a list to create every single tile for the game. Okay, so first let's add the values to the list. So for I equals 1, I less or equal to rows times columns, so that's the size of our grid. I will divide it by 2 because I want to add everything in pairs. So what I'm going to do is I'm going to randomly choose a tile to add. So it's going to be the seal random tiles. Okay, so that's going to give me a number between 1 and 6, and that's a random number. And I'm going to add that to the list, ds list add tiles list, and my value will be tile to add, perfect. And what I'm going to do, I'm going to duplicate this function because I want to add everything in pairs, so I make sure that I have a pair in the game to remove while playing. Okay, I'm going to shuffle this list, so I'm going to use ds list shuffle. I'm going to use this built-in function, that's why I'm using ds lists. And I'm going to create a grid. Our going to be tiles grid, the name of our grid. It's going to be a ds grid create. Okay, it's going to have columns +2 and rows +2 in size because I want an initial empty column and a ending empty column and row also, so I have always empty rows and empty columns at the beginning and the end of the grid. And I'm going to start to add my tiles to it. So for I equals 0, I less than columns +2, I plus plus, okay? And now I'm going to do a for loop with j from 0 to rows +2, increasing the j by 1, okay? And what I'm going to do is inside these two loops, I'm going to add my instances. So var instance equals to instance create, my initial x plus I times 32, my initial y plus j times 32, that's my x and y position, and my object can be my object tile. Let me just create here, object tile, there you go. Perfect. And inst dot I equals the I, the j equals the j value, so every instance knows its position into the grid. And yes, grid set tiles grid I j instance. Okay, so I'm setting this grid position with the instance, so I can reference to this instance by having the I and the j positions. Okay, and for I equals 0, I less than columns. So now what I'm going to do, I'm going to add the shuffle tiles to the list. So I'm going to also do a loop from I to columns and from j to rows. And let's just use the tiles grid, okay? And I'm gonna use an accessor to access the I plus 1 and the j plus 1 position. So I'm skipping the first row and the first column. And I'm gonna set my image index of this instance to the tile list, the accessor of the 0 position of this list, okay? And then I'm just gonna remove the 0 position of this list, so I can keep going through the list by accessing the 0 position, and that will work, okay? So let's add the sprite to the tile. Let me add a room and we can test this out, okay? So, sorry, I want the object controller, okay? I'll just add the object controller and let's run and see what happens. Okay, I got this nice weird effect. That's actually quite easy. I just forgot to stop the image index from moving, so what I have to do is set a create event and a quote in my tile object, and I'm going to do image speed equals to 0 and my depth equals to -y, so this should fix everything. And let's try it again. There we go. It's perfect. So we have this random tile set up correctly for our game. Okay, so now let's work with the scripts. We're gonna have 3 scripts as shown before, so we're gonna start the first one, and this is gonna be script f order. Okay, so this script is gonna take into an I and j position, a vector in the I and a vector into the j directions, and list. Okay, so let's create initial variables where I equals to argument 0. That's our initial I position. Let's do the same for the j position. Okay, initial j. For our vector I position, it's going to be our argument 2. Okay, vector in I direction, vj is going to be argument 3, our vector into the j direction. Okay, and our list equal to argument 4. Perfect. That's the list that we're going to update with the findings. And let's create 2 new variables, var n and m. Okay, so the first thing I'm going to do is an if check. So if the control tiles grid on our I position plus our vector in I and our JJ position plus our vector in J, okay, image index is equals to 0, so it means that is an empty object. It's no tile. Sorry, there we go. What I'm going to do is yes list add, and add to this list this exact position, so II plus VI times 100 and JJ plus VJ. Okay, so I'm adding to the list that we have found an empty position in that direction. And I'm gonna call myself again, but the script is gonna call itself by using the new positions. That's our I position plus our vector in I and a J position plus our vector in J. It will still add the same vector to keep going through, and our list. Okay, so this is how we do recursive calls of the script. That's basically it for the script. And we're gonna do script check direction. Okay, so this one is the script that's going to call the first order script, checking for the north, east, west, and south directions. So it takes an I and j argument and the list that needs to be gone through to put stuff into it. No, so var I, var j, okay, initial j, and the list. It's gonna be argument 2. Perfect. Our stuff. There you go. So all I'm gonna do, I'm gonna call the script f order, passing through our I, our j, and 0, 1, 0 direction. Okay, 1, 0 is gonna be running east, and I'm gonna copy it 4 times. I'm just going to change this vector around. So let's run west, and then change 0, 1. That's going to run south, and 0 to -1, that's going to run north. And with that, we have all the scripts that we need for the game. Okay, now let's add a mouse click event to the object tile. So whenever we click on this object, we start to do some stuff. No, so first let's check if our image index is different from 0, which means that it's an empty tile. If it's not an empty tile, we do stuff. If we're clicking on an empty tile that has been already removed, or one of the border tiles, nothing happens. So let's run our state machine. If it's not empty, I'm going to use a switch in global my state. Okay, And in case our state is equal to first click, and case state equals to second click. Okay, there we go. So if we're clicking the first tile, the first click, what I'm going to do is let's clear our lists. So DS list clear. Okay, global first order. Let's copy this and use it again and clear our second order list. So this means that we're starting fresh with clear lists. Let's add our indicator. That's actually our new object that we're going to create, object indicator on our X and Y positions. So this is just a blinking indicator on top of the tile to show which tile we have clicked. There we go. And now we can start coding RDMS stuff. First thing, let's check the first order of this tile that was clicked. So we're gonna check the directions north, south, west, and east to see if they're empty. So script check directions in our I and J and global dot first order. So we're gonna check for our I and J position, and we're gonna add whatever we find in the first order list. Then we're gonna do the same to check the second order. So what we're going to do, we're gonna loop through our DS list. So while DS list is not empty, the global first order list, we're gonna run some code. So the first thing we're gonna do, let's create some two variables, n and m. So first thing, we add our current position to the second order, so we don't lose the positions that were already in the first order list. So we're just transferring stuff from the first order to the second order list by using the accessor on the 0 position of the first order. Okay, let me just increase the size of this. There we go. Then the second thing we're gonna do is we're gonna get the n value. That's gonna be our first order 0 position, div 100, and let's get the m. That's going to be the same thing but mod. So this is how we get the I and the J from this list. So the first one gets the I position and the second one gets the J position of our grid. So script check dir and n and m, global second order. Okay, so it's going to check the 4 directions for this I and J position, and then we just delete this first order 0 position value. Okay, so we can keep going through this loop. So we're checking the second order. Okay, so this is how we're gonna check the first order and the second order directions. And let's add our global first click tile. Let's add the tile itself. Okay, so this variable is set, and we'll set our state to the second click state. Sorry, state dot second click. Perfect. Now for our second click state, so we have clicked the first one, we have run the first and second order lists. So now we have to click the second object. We're gonna check if the image index is equal to the global first click image index. So both tiles have the same image index, means that they're similar tiles. So we're checking everything like that. And we're also checking if we're not clicking the same tile again, so if we're not clicking ourselves for the second time. So if we have the same type of tile being clicked twice, and if we're not clicking ourselves, then we can run our code. That's everything that we're checking right now. Okay. Let me increase this a little bit also. There you go. So we have checked that. Now we have to check if we are adjacent to the tile that was clicked. So I'm gonna do that by using a formula that is gonna be the Y position of the first tile on the grid minus our I position. And if that is equal to 1, the absolute, so it doesn't mean which one comes first, it means that we're adjacent on the I direction. but at the same time I want to check if our J position is exactly the same. And I'm going to do the same, just switching around I and J. So I'm going to check if row-wise we're adjacent. Because if we are adjacent and if we are of the same type, we don't have to run all the code, okay? We know that we can remove this tile. So what I'm going to do is use a global first, click tile equals to image index, equals to 0. So I'm setting this to 0 and myself image index setting to 0. So what I have done is actually removed or hidden the tile because it was removed from the game. So else, if we're not adjacent, then we have to run our code to check if it is a valid move to remove this tile. So let's clear our global first order list. I'm gonna use that again. Okay, it should be clear already, but let's make sure. And do script check direction ij global dot first order. So we're gonna run the first order script to check all the valid positions for this. So now what I'm going to do is let's do a for loop from n equals to 0 to n less than the s list size. So what I'm going to do, I'm going to run through this list, position by position of this list, okay? And we're going to check if any position of this list actually matches one position of the second order list of the first click tile. So if the s list find index, okay, so we're going to look for the second order list, and the value that we're looking is the first order on the n position because we're going to loop through it. Okay, and this index needs to be different from -1, which means that we found one position that's actually equal in both lists. It means that the move is valid, so we can actually just copy this and set everything to image index to 0, meaning that we have removed the tiles. Okay, so let's destroy our object indicator. So instance destroy. That doesn't really matter if we actually got a valid move or not, we just destroy it because we're going to start all over when we clicked again. And let's set my global state to the first click state again. Okay. And with that, let's just do a create event here, just switch our speed. So image speed equals to 0.3. Okay, so it's not blinking really fast. Save and run. Oops, sorry, got an error. It looks like a typo. Yeah, it's a typo. So let's just set this depth because I saw it didn't show up. It should show up, so set it upwards on the depth. And let's check our alt tile left pressed. There you go. I was missing C on both locations. There you go. Save and run again. And let's try it. There you go. And it actually works. You can see that I can choose different positions and only valid moves are accounted for. Okay, so that's basically how we did the basic game. It's working very well. And thank you very much, you guys, for watching. I hope to see you guys next. If you like this video, please click on the like button. If you want to subscribe to my channel, please click on the subscribe button. That helps out a lot. And if you want to be notified when new videos are out, click on the bell button, okay? If you have any comments, doubts, suggestions, improvements, things you didn't like, please let me know in the comments. This video was created by one of the things that was asked for on the Game Mix forum. So if you have anything that you want to ask for to see on the next episode, please let me know and I'll create it for you. Okay, thank you, and I'll see you next.